Hi guys, how are you?
Hi.
Um, there is a cat in my room, but we do not have any cats at home. What should I do you think?
What is advice, guy?
I'm not sure. I mean, all of them became so brave when our cat got away. I mean, now they just feel as if our flat is their own. I mean, they go to and fro and all
Yeah,
in all the
I can show
directions.
him to you right now.
We need our cat back.
No. Here, look at him. He's chilling.
Right. Okay. So, I hope people would join. And now we're back to our formal semantics. Right. Last time we were discussing propositional logic, um, conjunction, disjunction, negation, and so on, and such thing as truth tables. Okay, so truth tables is um, a table that gives us interpretation of a formula. For example, a formula phi and c, okay, p and q can be presented in the form of a truth table. Okay. Um, we discussed conjunction, which gives us this thought of a truth table. Disjunction, which gives us the thought of truth table. It's page 97 in the textbook. Right. We looked into negation with the conjunction, when a conjunction is negated. And what we didn't discuss, I guess, is double negation. Double negation is very, very simple. It just loops us back to where we were. Yeah. Double negation of P, if P is true, then double negation of P is also true. Right. And then what we didn't discuss, I guess, is De Morgan's laws that involve two propositional letters. I remind you that P is a propositional letter, which means that behind this P we have a clause, some statement like the sky is blue, or the day is windy, or the dog is white. This is a propositional letter. So and this truth table gives us De Morgan's laws. Like each prepositional letter might be either true or false in a given interpretation. And then we get all those combinations. So if P is true and Q is true, then P and Q is true. Negation of P and Q is false. Negation of P is false. Negation of Q is false. Negation of P and or negation of Q is false, right? And so on. P true, Q false, P and Q false, negation of P and Q true, negation of P false, negation of Q true, negation of P or negation of Q true. Okay? So, which means that negation of P and one moment, negation of P or Q gives us an equivalent to negation of P and negation of Q. All right? Now, help me to fill out the lines. If P is true, Q is true, negation of P or Q gives us what? Help me, help me.
False.
Okay. If they both, right, if they both, yeah, certainly. Yeah, I guess, then we have false. If, okay, if P is true, Q is true, negation of P and negation of Q gives us what? Okay, negation of P or Q gives us false, right? Or
Right.
some, right. Now, negation of P and negation of Q gives us what? In case they're both true.
Gives us false.
Gives us false, yeah, I think. Both. So, false. What do we do if Q is false? What do we get? Anyone? Queen? What do you think? Donya? Seva?
Huh?
If P is true, Q is false. What do we get in case of negation of brackets? P or Q?
False.
False, right. We get false in this case. And what do we get if brackets negation of P and negation of Q?
False.
False.
False. Yeah. Again. Now, if P is false, what do we get? And Q is true. What do we get in negation of P or Q? That's easy, guys.
False.
False, right? And in case of negation of P and negation of Q.
False.
False again. Right. If they're both false, what do we get in negation of P or Q?
True.
True.
True. And what do we get here?
True.
True again. Because we have true and true, right? We get true out of this formula. So this shows us that negation of P or Q is equivalent to negation of P and negation of Q. All right? So, proven. So, these two formulas are equivalent. Now, yeah, right. Now we have P and Q. And we are reminded of the definition of entailment. So A entails B if and only if there is no circumstance in which A is true but B is not. Okay? So P and Q as shown here entails P because there is no such situation where P and Q is true, but P is not. Can you see that? If P and Q is true, then P is true, always.
Yes.
Yeah. Right. Does P entail P and Q?
No, I think.
Why?
Because P entails just itself and not Q.
Look, we have the formula for proving this. Yeah, explanation. There is a row in this truth table where P is true over here, but P and Q is not over here.
Mm-hmm.
So P does not entail P and Q. That's why. right? Now, we have a negation of P or Q, and the question, does the negation of P or Q entails the negation of P and Q? Okay? So, we're supposed to take a pen. Where's my pen? My pen. And a piece of paper. And then we start writing the truth table as a proof that it entails negation of P and Q or not, right? So we actually get this sort of table if P is true, Q is true, P or Q is, remind me. What is P or Q?
It means one of them is at least one of them is true. So
At
yes,
least
it's true.
one of them true. Yes, it's true. Yes. Negation of P or Q. Come on,
No,
guys.
false. False.
False, right. P and Q. If they both true. Come on.
True.
True. Negation of P and Q.
False.
False. P and Q. Right. Now, if P is true but Q is false, what do we get in P or Q?
P or Q, true.
True. Negation of P or Q?
And the negation of P and Q, I think true. True.
No, it's false.
False. It's a negation,
I
right?
don't remember. Just one of them.
It's a negation of something. Yeah, if something is true, then negation of something is false, right? So if P or Q is true, negation of P or Q gives us false. Am I correct?
Yeah.
I think we need
A definition?
notion. Yeah.
An example? Okay. So let's say P is, it is raining. Q is, it is windy. P or Q is, it is raining or windy or both. Okay? Negation is, it's neither raining nor windy.
Okay. Then it's
You remember that negation of P or Q is the same. We just proved that. The same as negation of P or negation of Q. Either it isn't raining or it isn't windy. And not both. Okay? So if P or Q is true, negation of P or Q is false. Yeah, everyone sees that? Are we good here? If not, let's try to come to the understanding. I mean, raise your hand if you're okay with that. What not?
Or how do you raise your hand?
Again, P or Q. If P is true and Q is false, P or Q gives us truth. For example, it's raining or it's windy. If it's raining, then the whole construction gives us truth. Okay? And now, negation of P or Q is a negation of P or negation of Q. Either it's not raining or it's not windy. And if it's one moment, if it's raining, okay, negation of P or Q should be the same that we actually did over here. Negation of P or Q is equivalent. Sorry. It's equivalent for negation of P and negation of Q. I mean both. It's not both raining and windy. Okay? So I guess Sonia win. Switching. I guess Sonia
What?
is correct here. Yeah. So the thing is, negation of P or Q is equivalent to negation of P and not or and negation of Q. So in terms of raining and windy, like P is it's raining, Q is it's windy, P or Q is it's either raining or windy. Negation of that is it's neither it's not raining and it's not windy. It's
It works like
not
multiplication.
both. It's not both. Yeah? But we have here the negation of P or Q, which is different from over here. This is, it's either not raining or not windy. So in case one of them renders true, it's true, right?
Mm-hmm.
So,
In case one of them is not true, it's also true.
yeah, so it renders true if one of them is not true, which is our case here. So negation of P or Q over here gives us true. Yeah, we get false if they're both true. We get true if one of them is false, which means we get true over here.
Mm-hmm.
And I guess we should get true in case
Negation. Yeah.
both, yeah, of them are false. Yeah, so for P or Q, we get true, 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 false. Right? Now, let's come to P and Q. First line. What is it?
True.
True. Second line.
False.
False. Third.
False.
False. And last one.
False.
False. Yeah. Now, if it is a negation of P and Q, then what do we get if P and Q are both true?
False.
False. Yeah. What about the second line?
False.
False, right? Because in this case, we get what we discussed before. This case, right? If one of them true, then the whole thing is false. If at least one of them. So the third is therefore
False.
false. And what about if they both are false?
True.
Should be true.
Mm-hmm.
Okay? Guys, everyone, are you good with that? Is it obvious? Any question? Probably not. Now, Lena, can you form a sentence if P is it is raining, Q is it is windy, and we get negation of P and Q? And everyone, think of a sentence.
Did you see me? I didn't hear.
Yeah.
So it is neither windy nor raining, or like what you just said.
Neither windy nor raining. Yeah. Should be that. Yeah? Do you agree, guys?
Wait, is it the negation of P and Q or the negation of P and the negation of Q?
It's not both windy and rainy.
Wait, so we have P and Q and we want the negation of that, right?
Yeah.
So it should be it's either not raining or it's not windy. Like
Yeah,
even
sure.
if one of them is false, then it's going to be
Yeah, agreed. I misunderstood.
Okay. So if they're both false, if it's not raining and it's not windy, and then we get a negation of it, then it's not windy and it's not raining.
And the negation is
It's
true.
not both raining and windy. So we get true. Can you see that? Oля? Sorry,
Yeah, and
just yeah, I'm trying to show this thing. Okay, I put it into the Telegram. P and Q. It is raining and windy. P or Q. It is raining or windy or both. Negation of P or negation of Q. It's not raining or it's not windy. Negation of P and Q. It's not both raining and windy. Negation of P or negation of Q. Either it isn't raining or it isn't windy. Yeah, double negation P, it's not the case that it isn't raining, which means it's raining. Yeah, but I do not have in my list the case that we're looking at, right? Negation of P and Q. One moment.
notice here, it's not both raining and windy, and it is equivalent to either it isn't raining or it isn't windy.
One moment. So, not it's raining and it is windy. Yeah. Okay. One moment. I need my paper. Anyone wants to discuss it? Do tell. If both P and Q are false, then what do we do? So it is raining is false. It's not raining. It's windy is false. It's not windy. And negation of the situation that it is raining and windy gives us true.
Mm-hmm.
Yeah. Are we good now?
Yes.
Yeah. Oля, are we good now?
Yes.
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 Right. So we should remember, and this is not obvious, that negation in case that both P and Q are false, negation of the conjunction is true. Ooh. Right. Now there is this thing as scopal ambiguity. Scope is such thing where negation, for example, can include in its sphere, can influence more or less only part of the sentence, or it can influence the whole sentence. I mean, there are different scopes of negation. Jody didn't consult both Troy and Worf. And then if negation scopes over just non-groups, Troy and Worf, we get Jody consulted neither Troy nor Worf. And if negation scopes like over the whole sentence, over the predicate, then we get it is not the case that Jody consulted both Troy and Worf, although he might have consulted one or the other. Okay. There are actually better examples, but nothing comes to my mind. I'll check. One moment. Anyone can think of an example of scopal ambiguity?
Ambiguity.
Can you give me an example instead of correction? So, actually, for example, you don't have to leave. Yeah, I asked for an example from the LLM, and they give us that. They're good with these things. You don't have to leave. One scope, reading A, is it is not required that you leave. Leaving is optional. Permission to stay. Now, you don't have to leave. Might be it is possible, allowed that you don't leave.
I mean, I think both of those mean the same thing that you just said.
Logically, they are distinct. Okay.
I mean, not really, because
Okay.
I mean, optional means like the whole thing of
mean,
optional is that it is not necessarily present. Like, yeah, that's the definition of the word.
okay. Let's think again. Every student read a book. For each, it's not a good example because it involves quantification, but still, if we're talking about scope, I was always given examples like that. For each student, there exists possibly a different book that they read. Yeah. And with the other scope reading, we get there exists one particular book that every student read. Every student read a book. Okay? Probably that would be their book in this case. And that's how English as a language solves these problems. Okay, that's difficult. Okay, I suggest we think the examples for scopal ambiguity. Right, let's read on. So, with the example that was suggested, Jody didn't consult both Troy and Worf. This can be represented as we have two prepositional letters. Jody consulted Troy and Jody consulted Worf. So we have a negation of a conjunction of both propositional letters. Yeah, so it's not that Jody consulted Troy and Wolf. Yeah, so he didn't consult either. Okay? Now, if we read it as a negation of P and negation of R, sorry, in A, right? We would have, it's not the case that Jody consulted both Troy and Worf, although he might have consulted one or the other. And the B case, neither one nor the other. Is that correct? Do you agree? Did I understand that correct? Let's discuss, guys. We have Jody consulted Troy, Jody consulted Wolf. The negation of P would be Jody didn't consult Troy. The negation of Q would be Jody didn't consult Wolf. So B case is Jody didn't consult Troy and Jody didn't consult Wolf.
Mm-hmm.
Right? So Jody didn't consult. Jody consulted neither Troy nor Wolf.
Mm-hmm.
A example over here in 16, right? So 16A goes for 17B. Am I correct?
Yes, so that, yes.
Yeah. So, 17A is Jody consulted. It is not the case that Jody consulted Troy and Wolf. So, it is not the case that Jody consulted both Troy and Wolf.
Mm-hmm.
Then 16B corresponds with 17A. Do you see that?
Mm-hmm. Mm-hmm.
Mm-hmm. Right. And here we see that in 17A, the scope of negation is the whole conjunction of P and R. And in 17B, negation scopes over P and negation scopes over R, not over the conjunction. Do you see that? Yeah, Ola said that she sees that. Good. So not mistaken. I can't be, right? So really need your brains here. And this is how we demonstrate the difference between two readings of the sentence 15. Jody didn't consult both Troy and Wolf. So we can explain people why there are two readings of this sentence. And this is what we call scopal ambiguity. Right. Okay. Go on. And we call it if negation scopes over one prepositional letter and it scopes over another prepositional letter, the case of 17b, then we say that negation takes scope under the binary connectives. Should be that. So first we apply negation to the prepositional letters, and only then we conjunct them. This is negation takes scope under the binary connective. And if negation takes scope over the binary connectives, this would mean that first we conjunct the prepositional letters and then we apply negation. Yeah, so we can show this with brackets. It's like brackets with multiplication or I don't know. Yeah, math thing, right? Are we good here? Now, actually here we will have the term inclusive disjunction and exclusive disjunction. This is about the or operator disjunction. An inclusive disjunction yields a formula that is true when both of the disjuncts are true. An exclusive disjunction operator yields a formula that is false unless exactly one of the disjuncts is true. So, an exclusive disjunction formula is false when both of the disjuncts are true. Now, can you write this thing as a formula in the chat of Zoom? Can you try writing this with brackets? What do we call inclusive disjunction, and what do we call an exclusive disjunction? So, can we do that, or do we leave it for homework? Exercise 10. I think we need to think about it a bit. What do you say? Well, I think that we can draw a truth table for an inclusive, an exclusive, or and that would be if P is true and Q is true, then inclusive or P or Q is true, and exclusive should give false, because it's not or, it's both. Okay? Then if one of them is false, we get true both for inclusive and exclusive, and if both of them are false, then we get false both for inclusive and exclusive. All right? Actually, we've got, so the thing is that exclusive or gives us false if P and Q are both true. Then exclusive or is false. Right? So, we actually, I can see that. Oh, I see that's inclusive, yes. Thank you, Sonia. Actually, I see that we have even different ways to write it. This is inclusive or, and there is a sign. Oля, do you have this in math?
Yeah, this
And
is XOR.
What is it?
Well, it's called in informatics also XOR, which is basically exclusive or.
Yeah.
XOR, XOR, yes.
Yeah. So exclusive or. I didn't know that actually. I just saw it over here. Right? So, P or Q gives us inclusive or, and P or, how do you read it? P or Q gives us exclusive or. Ola, do you have any reading for this side?
What do you mean?
I mean, we read inclusive or as P or Q. How do you read this?
I would just say XOR,
XOR? Okay.
but it's
Oh.
not like
You don't read.
I'm not sure
Yeah.
about the actual. Yeah, we don't read.
Right. You don't read that. Okay. So I'm going to copy the thing, explanation, and send. No, I cannot send it. Sorry, guys. I'll make a table or something and send after the lesson. The difference. Okay, now, or in English, is it inclusive or exclusive? For example, you can have tea or coffee.
Exclusive?
Can you have both?
I think what the question presumes what you have, what you can have on the one, no?
Probably. Well, literally, this sentence allows both. Yeah, but contextually, it is often implicated that not both.
Okay, but
Yeah,
in some contexts, it still implicates that you can have both.
yeah.
Li-
So, right.
Like in some contexts, I think that in some contexts it can mean allow both. For example, if you if you if you show workplace to a new worker and say here you can have tea or coffee, it means that you can have both there.
Yeah. So, it's it's pragmatics. Yeah, it's conversational inference. It's not the core truth condition. Okay, so therefore, literal meaning of English or is inclusive, right? But if we have either or, but not both, yeah, you can have either tea or coffee, then or gets exclusive meaning. Okay? Yeah, we're good here. I don't have a doctor's appointment today or tomorrow. Exclusive or inclusive?
In inclusive.
Do you agree, guys?
Yeah.
Let's check.
Inclusive?
Should be inclusive, right? One moment. Getting the answer. So, yeah, should be inclusive. It is inclusive. If it were exclusive or under negation, it would mean either both days or neither, which is not the natural reading here. Okay? So, yeah, I don't have a doctor's appointment today or tomorrow is inclusive. Now we are moving to conditional and biconditional. So we have conditional statements. If A, then B in every language. And we can present the meaning, the semantics of it, using truth tables. Yeah, and we use the arrow, sometimes this sign, to represent it in writing. So if we are using our propositional letters, then we get the form if P, then Q. Yeah, over here in natural language. If it's sunny, then it's warm. Yeah, and in the phrase if P then Q, P is called the antecedent and Q is called the consequent. So the antecedent is it's sunny and the consequent is it's warm. Win, are you with us? Win?
What? Huh?
Are you here with us?
Ish.
If it's sunny, then it's warm. What is antecedent and what is consequent?
The, it being sunny is the antecedent and it being warm is the consequent.
Good. You're with us. Just checking. Right. And as we have negation, then we have it's sunny and it's warm. It's sunny and it's not warm. It's not sunny and it's warm. It's not sunny and it's not warm. Okay? So, then we have this formula. If sunny, it's warm. Okay? In which case this formula is false.
You want me to just like give you the truth table?
Well, let's do the truth table.
Okay, sure.
If P is true and Q is true.
Then I guess, yeah, that's true also.
True. P is true, Q is false.
False.
False. P is false, Q is true.
I mean, that's ambiguous, I think.
Mm-hmm, mm-hmm,
Okay, we do not know.
mm-hmm.
And if P is false, Q is false,
We also don't know, I think.
we also don't know. Okay. Hopefully we are going to discuss it further. Here's your truth table. Yeah, so if P is true, Q is false, it's false. If P is false, Q is true, then it's true. If it's not sunny, yeah. If it's not sunny, the statement, if it's sunny, it's warm, is not influenced by the truth value of P, okay? Or the truth value of both propositional letters. Can you see that? I mean, if it is sunny, but it's not warm, then the condition, if it's sunny, it's warm, gives us false.
Mm-hmm.
But if it's not sunny, then the condition, if it's sunny, it's warm, it's like, well, it's not sunny right now, but if it were sunny, then it would be warm, right? And doesn't matter what's on the Q side. If P is false, somehow this formula gives us true.
What?
It's
So
not-
is it just like, is it possible that that's the case? Does it check out in that situation? Is that a world where they can coexist?
You see, we do not discuss what will happen if we're just checking, yeah. And if we give false value to this formula, then it just doesn't work, and it exists somehow without this false value, and it's true without this situation, this false value. Yeah, that's not intuitive. And we're given this example. For example, the moon is not made of green cheese. Does that mean that if the moon is made of green cheese, then I had yogurt for breakfast this morning is true? Probably not.
Intuitively not.
Let's read it, because it's really a difficult piece. One might think that an indicative conditional is true only if the corresponding argument is valid. But as we have seen there, an argument is not made valid merely by virtue of having a true conclusion. Its validity depends on whether the conclusion is true in all cases where the premise is true. So, one might reasonably argue that English indicative conditionals too cannot be judged as true or false. That's why we decided to put question marks. You remember we did that, and that's reasonable based on a single case. In order to capture the truth conditions of indicative conditionals, we would need to talk about multiple circumstances or interpretations and not just a single one. Okay, but the connectives of propositional logic, so far that we're talking about propositional logic, are truth functional. Their truth value depends only on the truth values of their constituents. That's what I was talking about when I said that we just checking the truth values after feeding the truth value of premise into the formula, premise and the conclusion. So we do not evaluate the circumstances. We do not evaluate interpretation. We're just checking truth values here. And this is how it works. If premise P is false, then if P then Q would be true. Because P to Q does not depend on the truth value of P or Q if the premise is false. Can you see that now? Guys, are we good here? This is a difficulty. And fun fact here is that if P then Q gives us the same, it is an equivalent of not P or Q. Okay? All right. Let's do the truth table. Not P or Q versus P to Q. If P is true and Q is true, what do we have for not P or Q?
We have true.
We have true. As in P to Q. If P is true and Q is false,
We have false.
what if we get false, right? as with P to Q. If P is false and Q is true, what do we have?
True, right?
True, as here. If they're both false, what do we get?
Also true.
Also true. Can you see that? Right. This is just a fun fact. Okay. So, exercise. Get ready with your pen and paper. Exercise 12, which of the following argument forms are valid in propositional logic? Okay, let's say we need time to think about it, and as we did exercise 10, then exercise 12 for you to think about. And we go on. Okay, at home. Do you agree? Or shall we try and think about it? I think we need time here to think. So exercise 12, we think at home. Guys, give me the feedback. Okay?
I think to боже мой, как бы больше времени требуется
We
на
need
то,
more
чтобы это
time.
продумать и потом перевести на английский.
Right. We need more time to think it over and then translate to English. Yeah, I see. So that's why I suggest we think about it at home. Right. And now we come to what? Okay. Now we come to not all true conditional have true converses. It may be true that if it rained last night, the lawn is wet. You remember that example? Yeah, false that if the lawn is wet, it rained last night. So not everything we can convert. But some conditional, yeah, can be turn opposite, can be convert. Do have the property that the converse hold. When they say holds, this means that it renders true. So the conditional holds and its converse holds. If yesterday was Sunday, then today is Monday. If today is Monday, then yesterday was Sunday. If today is Friday, then yesterday was Thursday, and vice versa. And this is if and only if. Today is Monday if and only if yesterday was Sunday. Today is Friday if and only if yesterday was Thursday. So yesterday's being Thursday is a sufficient condition for today's being Monday. Yeah, and today is Friday is a necessary condition. Sorry. Yesterday's being Thursday is a necessary condition for today's being Friday. Okay. And this is called a biconditional connective. And conditional connective we can write as an arrow, and biconditional connective, if and only if, we can write this way.
Mm-hmm.
So P, if and only if Q is true, whenever P and Q have the same truth value, either both true or both false.
Mm-hmm.
And now we come to the truth table over here. And can you see that it is different from the truth table of if P then Q? Yeah, what's the difference?
The difference is in the third line. If
Yeah,
if P then Q with так false true uh, 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 in the case with if and only if in the third line the result is false, and in conditional case the result is true. By conditional false, conditional true.
yeah. You see, in the third line, we can like turn this over 180 degrees, and then the premise would be true, so we can use it more or less. That's why it works actually. Because in the last line, this just doesn't apply, right? That's why it gives true.
Mm.
And here it applies because we can convert it and make Q the premise. So that's why it gets the false meaning as in the second line.
Mm-hmm. The third and the second line could be exchanged by themselves, by each other.
Yeah, that's right. All right. So we're finishing here. We're finishing here because we ran out of time, more or less. I remind you that we do exercise 12 at home, thinking about it. And today we studied conditionals and biconditionals. And we found out that if premise is false, then the truth value of the conditional renders a very unexpected result true.
Mhm.
So, questions, suggestions?
Thank you very much.
So,
Thank you.
חג שמח. שבוע טוב. And
Welcome.
see you next week.
Bye.
Bye.
Bye.